Hello everyone, I am your classical machine learning trainer. I am your classical machine learning trainer where I will explain the classical machine learning in detail. So what topic will cover? We'll discuss on it. I will not in waste of time because I'm training. So I'm classical machine learning trainer. If you need a basic Python trainer, already there is another uh, this is the same channel but where they are providing the basic python basic to advanced, and there is another where we are explaining the basics equal to advanced equal, and also we are explaining the uh, math and linear algebra probabilistic. So these things, so basically I am just think about the classical machine learning. So what I am expecting for you. So basically, I'm expecting that you should be know the Python and math. If you know that, you can easily survive this machine learning algorithm. Even in our channel, the other trainer is providing the Python and math, so you will learn it from there. So let me start by one topic, how to explain, how to debug it, how to what topic we'll discuss today. So today we'll discuss the supervised learning. Okay. So first of all, we need to understand what is the supervised learning. Let me explain to you. So supervised learning. Supervised learning is a type of machine learning, right? So supervised learning is a type of machine learning where the model is trained using the labeled data. So what is the meaning of labeled data? Right? We need to understand what is the meaning of labeled data. So labeled data means each training example as an input. So now what is the label data? Label data means each training example as an input and output. So basically label data means for the data set has an input and output, right? So we know that this is input, and how do we are detect the output? We have a in the data set that is called label data. The model learn the relationship between input and output, so it can be predict output for new and unseen input. So why we predict the label data? So let's suppose input, we have seen that the email, if email contain the free word, so we can put spam. So we know that relationship between the input and output. So spam email detection, right? Email text spam or not spam. So basically classification. So we can classify between two data because the relationship between the input, if input contain the spam, means input contain the free. So we can put the spam. Spam email detection. Input email text, output spam or not spam classification. House price prediction, input square footage location. So we know the output price, right? So we can identify the house price prediction. If you know the email text, spam or not spam, this is an example of classification, right? These are the type of supervised learning. So what type of supervised learning we have? So classification and regression. We have a two type of supervised learning. One is the classification and regression. What is the meaning of classification? What is the meaning of regression? Classification is pretty categories. Yes or no, red and blue, spam and not spam. This is called the classification. That not a continuous value, right? Regression predict the continuous value, price, temperature. So we can see the decimal values also. So that is called the classification and regression. Everything understand till now? Let me move. So now example real life analogy. Consider instructing a child to recognize a various fruit. Right? I'm just giving the real life example. Consider instructing a child to recognize the various fruit. Input. Image of fruit. characterized by attributes such as shape, color, and size. Output, the designated name of the fruit, apple and banana, right? So the by presenting numerous examples like child, this shunt, this pattern, and subsequent can be identify unfamiliar fruits like dragon fruit, right? If we are put the characteristic label, that is called the dragon fruit. So now I am giving the one example classification. Predict the iris flower species, right? Predict the iris flower species, right? Dataset. The re-on iris dataset will be utilized the which comprise, right? Feature: sepal length, sepal width, petal length, petal width. Target: flower species. Setosa, Vargicolor, Virginica. I want to just show that is the iris flower, and so we can understand this is a petal length, this is settle length. So we can understand this is a petal, this is sepal, right? So we can understand the vibe of the flower. The smaller flower we can say petals and the sepals. Just I'm giving. This is very common example we are using. So we can continue with the example in the next part, but this is a part one. You can understand, so we can understand supervised learning. I will tell you the what are. So we'll cover ML supervised learning, ML unsupervised learning. We'll cover also time series algorithm. So these are the very good things we'll cover, right? So we'll start, right? Thank you, everyone. Please go into part two. Part two, I will be explaining the example. I think it will be starting the couple of sec. You will get the part two. So I will be sequence one, two, three, four. You will get it.